Now we're going to talk about exponential functions. And an exponential function is simply a function that has your variable as the exponent, as we can see here in this example, f of x equals a to the x, where a is representing some number raised to the power of x. And here we want to keep in mind a cannot be equal to 1, and a is going to be greater than 0, and x, the exponent, is representing any real number. So let's look at an example of this and see what we have. F of x equals 2 to the x. And if we look at graphing this particular function, we could simply make an xy chart just like we have in the past. So I'm just going to start by picking values for x. And I'm going to start with letting x equal 0. So then we would have 2 to the 0 power. And keep in mind, if you have anything raised to the 0 power, that is simply going to be equal to 1. And then if I let x equals 1, we're going to have 2 to the first power. And of course, 2 to the first is simply going to be 2. And if I let x equal 2, we would have 2 squared. And 2 squared is 2 times 2 is 4. And then let's see if we pick some negative values. If I let x equal a negative 1, we have 2 to the negative 1. Now, how do we handle a negative exponent? Well, first we can make the exponent positive, and keep in mind this is understood to be 2 to the negative 1 over 1. So to make this exponent positive, we're going to move the 2 to the bottom, and we would have 1 over 2 to the first power, which is simply 1/2. And then, of course, if we let x equal a negative 2, we would do the same thing. We would have 2 to the negative 2, and we want to make the exponent positive, so we're going to move that to the bottom, and we would have 2 to the positive second power, and then 2 squared is simply 4, so we would have 1/4. So now let's see what happens if we were to plot these points. And let's see if we go here we have at 0, we're at 1, so at 0 we're up here to 1. And at x is 1, y is 2, so here at 1 we're up 2. And when x is 2, y is 4. Let's see, make sure I did this right. At 1, we're up at 2. That should be here. And if you notice this curve, the graph is going up very rapidly. And if we plot negative 1 here at negative 1, we're only at a half. And at negative 2, we're only here at a fourth. And here we can see the graph is increasing then very rapidly. And a lot of times if you hear the term something is increasing exponentially, then that means that it's going to increase at a very rapid rate. And that's what's happening here. As we go from left to right, it starts off slow, but then it starts to really increase at a very rapid rate going upwards. Okay? Now, if we look at this function, we want to determine what is the domain and range. So if we were thinking of the domain of this particular function, what values can x take on? Well, if we look here, there's no breaks in the graph, and it goes to the left forever, and it goes to the right forever, so it looks like the domain would simply be all real numbers, and that is the case. And of course, then if we want to determine the range, again, here, it looks like the graph goes up forever, but if we notice, the graph does not go down forever because over here at the left, this graph is going to get ever so closely to the x-axis, but it's never going to touch or cross the x-axis. So therefore, the range is going to have to be greater than 0. Okay? And we will also notice, do we have a y-intercept? Well, we know there's no x-intercept, but do we have a y-intercept? And the y-intercept is going to occur right here at 0, 1. Okay, and also if we look at asymptotes, we will have a horizontal asymptote right here at the x-axis where we have y equals 0, which would simply be the x-axis. Okay, and one thing I want to point out here, The function, notice here, is increasing. So function f is increasing. If we go from left to right, notice this graph is going to be increasing as long as our a value up here above is greater than 1. If a is greater than 1, and in this case, the a value we're talking about here is a 2, that's greater than 1, so therefore it is going to be increasing. But then if the function f is going to be decreasing if your a value is between 0 and 1. So in other words, if you have some fraction here between 0 and 1, the graph will be decreasing. Okay, so here are some basic properties with your exponential function. All right, so now let's see what happens if we have the function here. Same thing, except for instead of 2 to the x, we have 2 to the negative x. So again, I want to start out by picking some values for x. And we'll start out the same way. If I let x be 0, once again, we're going to get 2 to the 0, which is simply going to be 1. And if I let x equal 1, we're now going to get 2 to the negative 1 because there's already a negative sign here. So if we have 2 to the negative 1, notice now that's going to give us 1 over 2. So we have 1/2. And if I let x equal positive 2, then we're going to have 2 to the negative 2 again, because again, the negative's already in the function. And that's going to give us 1 over 2 squared, which would be 1/4. Now, what happens if I pick a negative value? Well, we're now going to get 2 to the negative 1, and the two negatives make it a positive, so therefore we end up with simply 2. And if x is equal to a negative 2, we would get 2 raised to the negative second power. Again, the two negatives make it positive, so that would be 2 squared, which is 4. And if we were to plot these points now, hopefully you can kind of see what's happening. If we have the point again, 0, 1, 1, 1/2, so at 1 here we're only up at a half, and then at 2 we're at 1/4, and at negative 1 we're up to 2, and at negative 2 we're up at 4. Now if you notice here, what's happening with the graph? Well, now our graph is decreasing. And once again here, it's going to get ever so closely to the x-axis, but it's never going to touch the x-axis here. Okay, so if you notice here, the graph is now decreasing. And you may be thinking, well, wait a second, you just said that if our a value up here, we just said that if the a value is greater than 1, it's going to be increasing. Well, we've changed the exponent though. Let's see what happens here if I was to rewrite this. If we had the function f of x equals 2 to the negative x. If I was to think about rewriting this, if we have 2 to the negative x, how do we make this exponent positive? Well, that would be 1 over 2 to the positive x. And really, couldn't we think of this as 1/2 raised to the x power? So if you notice here, this function is really 1/2 to the x, and here this a value is equal to 1/2, so therefore the graph is decreasing. Now let's go back and see what we can remember. I want to quickly review something over here at the side. If we were to look at the graph of y equals the square root of x, hopefully we remember this is your square root function, looks like this. And do you recall what happens if we put a negative on the inside of the function? What effect does this negative sign here on the inside of the function do? Well, hopefully you remember that's going to give us a reflection, and that's going to be a reflection in the y-axis. So the graph, instead of curving here to the right, is now going to curve to the left. Well, if we go up here and look closely, we have this same negative sign, this negative here, and again, this negative is on the inside of the function, so that's going to cause a reflection with the y-axis. So I want you to imagine if we were to take and reflect this graph 2 to the x in the y-axis, then we're going to end up with our current graph, because if we reflect this, the graph would look like this. So this here is the graph of 2 to the negative x. So once again, all of those properties we learned with the transformations of our functions before are still going to be true here, because if we put a negative on the inside, that's going to give us a reflection here in the y-axis. Okay? So to make that point a little bit clearer, let's look at the following examples. If we have f of x equals 4 to the x, well, what effect is this 4 going to have as opposed to this being a 2? Well, hopefully that's somewhat obvious. Uh, if this was a 2, you're having 2 to a power, but if we make this a here a 4, then it should make sense that we know we're going to always cross here at the uh, y-intercept 0, 1, but because of this 4, it's going to make the graph increase. So whereas maybe 2 to the x looks like this, then here this is going to increase at a much faster rate, because instead of having 2 squared, here you're going to have 4 squared, which is 16. So the graph's going to increase maybe a little bit sharper. Okay, so here we have our function f. So this is roughly what the graph would look like for 4 to the x. Okay, and now we want to look at what does g of x. Well, notice here we have 4 raised to the x plus 2. Well, what effect does this plus 2 here have on the graph? Well, if you remember, the x plus 2 here is on the inside of the function, so that's going to shift our graph left or right. And because it's on the inside, remember, this is where we could kind of think of taking x plus 2, setting that equal to 0, so x equals a negative 2. It's going to move the graph 2 places to the left. So if we go 2 places to the left, this point here, the y-intercept now is going to be here, and our graph would look something similar to this here. And this would be function g. And then if we look at h of x, notice here we have 4 to the x plus 2, so we know that's going to move us 2 to the left, but then we have this minus 3, and that's going to move the graph down 3 units. So we're going to go down to negative 3, so this point then is going to be moved down. Now be careful. This point right now is already at 1, so if we go down 3, 1, 2, 3, we're really going to be at a negative 2. So be careful with this one, because this original point over here is not starting at the origin, it's starting at the y-intercept here of 0, 1. So our y value is already 1, so if we go down 3, that's going to put us at a negative 2. Now keep in mind, the x-axis, remember, is our horizontal asymptote. So that's going to also be moved down 3 units. So that means at negative 3, we would have our horizontal asymptote for the graph 4 to the x plus 2 minus 3. So then therefore the graph's going to look something like this, where it's never going to cross the horizontal asymptote here at negative 3. Okay, so I want you to realize, even though we're talking about this exponential function, all of those transformation properties we talked about before are still going to hold true here if you're adding something to the inside of the function or on the outside of the function.